So now that we have a database inside PHP we need to talk about how to set up a table inside our database, or multiple tables, since we can have many tables inside our database. And in order to do that, we're going to program this into our database using SQL code, which is something that stands for Structured Query Language, which means that we're querying the database using this code here in order to manipulate the database and maybe create tables or insert data or select data or delete data, or there's many things we can do using SQL. And SQL is something that is not really too difficult. It takes a little bit of memorizing to do, but a lot of the code that you write using SQL is going to be pretty much the same. So it's not really like learning PHP where you have to memorize a lot of different code. It's more about learning the same queries, so to speak, in order to manipulate the database. So the first thing we need to do here is make sure that our database that we created in the last episode is selected over here on the side. So you need to make sure you click it. Otherwise, we're going to be writing SQL code for something else outside, on the side here. We don't want to do that because we want to make sure we select our database. So with our database selected, you can go up here in the SQL tab. And in here, we're going to go ahead and start writing some SQL code so we can actually write some instructions to our database for it to do something like, for example, creating a table. So I hope this is big enough, because it is quite tiny. I guess I can zoom in a little bit more so you can see a little bit extra here just to make sure that you can actually see what is going on, because it is quite a tiny console that we can write into here. So now when it comes to creating a table, there's a couple of different concepts that we need to talk about before we get started here, because we do have data types that we can insert inside a database. We do also have something called signed and unsigned. We do also have some different commands like auto increment, which means to be automatically assign numbers to a certain column. We do also have columns that we need to talk about. We have columns and rows, which is like columns is the vertical, and then rows is the horizontal. We have some different concepts that we need to talk about. But what is important to know is that this video is kind of going to be a mega video. It is going to be a little bit longer than other videos because there is, like I said, quite a few things we need to talk about. But you need to see this video as something you can return to. So if you need to know a little bit of information about, for example, what a row is or what a column is, or what signed and unsigned means, what does a primary key mean, what is a foreign key, then you can come back to this video, and then there will be timestamps below so you can kind of like fast forward, so you can find a specific part you need to refresh your mind with in order to know exactly what that was. But just know that I don't expect you to memorize everything on the first go in this video here. We will get to do more code in the future. When we actually get into PHP, we'll also write SQL code. So, memorizing these things is not something I expect of you on the first go. So the first thing I want to talk about here is data types, because when it comes to inserting data, just like with PHP, we also have, integers, we have characters, like actual writing, like text and that kind of thing. We have dates, we have decimal points, that kind of thing. So we need to talk a bit about the different types of data we can insert into different columns, because when we create a table, we need to define a row, which is all the data we have for one entry. And then we have the columns, which is each individual piece of data we might have for one database entry. So essentially we would have, for example, a person. So we would have, first name, last name, age, hair color. That would be like the different columns. And then when we grab one row from the database, that is basically grabbing the entire person with all these different attributes that that person has. So we can actually pull the row out and display that data inside a website, for example. So we have, columns, and then we have rows. And each column inside a table needs to be defined with a data type in order to tell our database what kind of data do we expect to be put inside this column here. So for example, if we were to go in here and say that I want to define a integer data type, then we do have an int data type, which is basically when we have 4 bits of data we can insert as a number inside this column here, which is not a decimal point. So, just like a regular number like this. And one thing to note here when it comes to these different types of data that you can insert inside a database is that they all have certain amounts of bits you can store inside this specific column here. So for example, when it comes to a int, we can actually store a number that goes from, I actually just went ahead and wrote it out here because it's going to take a little while. But when it comes to a integer data type, we can store up to 4 bits inside this specific column here, which means that we can store up until minus this number here until positive this number here. So this is going to be 4 64 bits. I'm just going to go ahead and leave this for now because we do also have something called signed and unsigned we need to talk about. But this is basically the integer range that you can store inside a integer column if you were to choose a integer data type. So let's say, for example, I want to have a much larger number inside my my column here, because this might not be enough for my specific number. Let's say I want to store a money amount inside my database, and maybe that money exceeds this amount, which in that case you're a very lucky person if you have that much money. But let's go ahead and say I want to store even more money inside this database column. What I could do is I could also use something called a big int. And it is important to note here that we do have something called tiny int, big int. So we have many different types of integer data types that can store up to, different types of bits inside of it. But for now, we're just going to talk about the more common data types that you might want to use inside a database, because it is going to be quite a long lesson if we're going to list them all out. So let's just go ahead and stick to the ones that you might want to be using at some point. Then you can, by yourself, look up some of the other types if you want to at some point in the future. But for now, we have something called big int, and this can store even greater numbers. So in this case here, I'm not going to write it out, but this is going to be up until 8 bits of data, or 8 bytes it's called. The previous one up here is also 4 bytes, by the way, not bits. So essentially what you can store here is a much larger number, which again is also going to range from a negative number to a positive number. So you could, for example, write something like this inside of it, and it would actually be able to store it, because as you can tell, this number is much bigger than this number up here, which is the maximum for a int data type. So, we can store a lot bigger number when it comes to the big int down here. And you might be asking, well, Daniel, so if you're saying that this one can store a lot bigger number than this one, why don't we just use this one every single time? And essentially it all counts down to performance and that kind of thing, because we want to make sure that we don't take up more space than we need to. We don't need to get close to this number here, but this is plenty for storing, a certain type of data inside our database. Then performance will be better if you just stick to the data type that makes sense for that particular purpose. So don't just go around using the biggest data type that you can find. So in that case, you can always store the biggest number. So choose the one that makes sense for the circumstance that you might want to use it in. And now we do also need to talk about something else before we move on to characters and decimals and date times and that kind of thing. We can also go ahead and put parentheses behind these data types and actually define a parameter for these data types here. In this case here, when it comes to integers, it is a device width that we're defining in here. So if I were to write something like 11, this does not mean that I'm allowed 11 characters, like 11 numbers inside this integer. This means that the device width allowed for this data type is 11 numbers. And this is not something that is directly going to be affecting your website. This is something that is going to affect certain types of applications that is used to, for example, show data. For example, our MySQL software here has a console inside of it where we can actually show the data from inside these different columns. So if I were to set this one to 5 and I were to store, let's say, this number right here, then I wouldn't be showing this number right here inside my database. I would actually be showing this number right here, although this number is actually what is stored inside this column, but it's not shown inside this database because we defined a max limit for how much the device width is going to be when it comes to showing this data inside this database here. And like I said, this is not something that really affects your website when you define a number in here, because you can still show the full number inside a website. So a typical thing that we do when it comes to just making websites is we just define 11 in here as a default, which by the way is, from what I remember, also the default when you just write this. It is going to be the same thing as writing 11 inside the parentheses. So this is not really that important if you're just a web developer and you just want to store numbers that you want to show inside a website. But just out of habit, we're going to go ahead and write parentheses 11 to make sure that it is defined, because some database types, maybe some legacy databases or applications that needs to show this data, do need to have this defined. So it is better to have it than not to have it. Okay, so with that said, let's go ahead and talk about a float number. So we can also define a float, which is of course also going to be when you have a decimal point. So you can, for example, say you have minus something, this number right here, dot something, And you can, of course, have a max and a minimum that you can store inside when it comes to bytes. In this case, it is also going to be 4 bytes, which means that we can store, I'm not going to type it out here because it is, a long number like these ones up here, but essentially you have a minimum and a maximum, which is equal to 4 bytes that you can store inside this particular column here. The same thing goes when we have something called a double. So we have something called a double, which can store much larger decimal points. So just like we have up here a int and we have a big int. So we have one for storing, a normal amount of numbers and one for storing a large amount of numbers. The same thing goes for float and double. This is a small amount of numbers, and then this one down here can have a lot greater amount of numbers inside of it when it comes to like decimal points and that kind of thing. So we do have different data types. Again, just like with numbers, we have the same thing when it comes to decimal points. And then we do also have something called varchar. Now, varchar is when we have to do with characters. So let's say I go in here, we can also create the parentheses, which is actually something you should do because the default is going to be 1, which is this right here. And that is not really useful for anything because that means we can store 1 character inside this column here. So it is, you should create parentheses outside varchar in order to define something here. So in this case here, we could, for example, say 10. So what this would basically mean is that I can store 10 characters as a string inside this data type. So if I were to write Daniel, this would be able to be stored in there. But if I were to write something like Danny Kossing, which is going to be more than 10 characters, it's going to cut off the last parts of this string here because we only allow 10 characters inside this column here. So depending on how many characters you want to allow inside this column here, you need to change this number in order to allow for that amount of characters. Now, when it comes to something like, let's say, a username, you could say something like 30 because, 30 characters for a username might be plenty, so you don't want to be able to store more than that. So we do have different numbers we can provide in here depending on the purpose of what we want to create inside our database. If you have a password, then we can also go down and say maybe something like 255 because we want to be allowing many characters for a password, but I have rarely seen anyone use more than 255 characters when it comes to using a password. So of course, you can define different things depending on the purpose that you want to allow the person to insert inside this particular column here. And just like before, we do also have a certain number of bytes you can store inside a varchar data type. So in this case here, it would be in the range of something like, and again, this really depends on the database because some databases only allow for 255, which is why I use that one as a maximum. But you can also in some databases store up to 65,535 bytes. So, it really depends on the database type you're using. In our case, I do believe we can store many bytes inside this, inside our database here, but 255 is kind of like the typical number that you define inside a varchar data type, because then you know that it can be stored in many different types of databases because this is the maximum for some databases. So 255 is also plenty, in my opinion, for storing, characters because, we have other data types for storing much greater number of characters. For example, we do also have a data type called text. And just like before, when we talked about int, big int, float, and double, if you want to store many characters inside a column, you can just use something called text, which is going to just be defined as text. And then you can store, for example, a blog post or a big comment for a post inside your website that has a lot of characters and text inside of it. So using text for example, comments and blog posts and that kind of thing is kind of what we need to use this data type for. Whereas varchar might be something used for usernames and passwords, something that's not a huge paragraph that needs to be written inside your website. So again, choosing the proper data type for a certain type of data or usage inside your website that is appropriate to the amount of characters that you might be using is something you should be doing. But now the last type of data type that I want to talk about here is something called date and date time. So we have something called date here, which is basically when you want to create a date for a certain moment in time. So for example, today it is the year 2023 and it's May month, which means 05, and then it's the 14th of this month here. So we do have different types of formatting when it comes to our date and date time and that kind of thing. So the formatting is something we need to be aware of when we upload a date to a database, because if we don't format it correctly, it is not going to get stored inside a database. So when you write PHP code, you want to make sure you format it in the same way as the database is. So we do also have something called date time. So we have date time, and that is basically the same thing. So we can actually copy paste this, but we do also have the time. So if I were to go in here and say that right now it is 11:30 in the middle of the day, so it is the 11th hour, and then we have the 30th minute, and then we have the, let's just say, the 0th second of the day. So this would be 11:30, and then of course we go into not AM and PM, but we're going into, for example, 17 if it's 5 o'clock in the afternoon. So we go after this time format here. So these are the different data types that I want to talk about, but I do want to talk about something called signed and unsigned when it comes to using numbers up here. Because let's say we have this integer example here. Let's just go and delete everything else. Now, we did talk about there being a certain number of bytes available inside these different data types that we have in here. And when it comes to an integer data type, we have 4 bytes available to us. And that basically means that we can range from this negative number here to this positive number here. However, if I were to go in and say I want to define my integer as signed, this right here means that we can actually store a negative number inside our database column as well. So this would be this range that we have right here, but I can also go in and define this one as unsigned, which means that we don't want to store negative numbers inside this particular number column. And that opens up a little bit of options for us, because right now we only have 4 bytes available, which means that this is the maximum positive number we can use. But when we cut out the negative numbers, we can store from 0 until a much greater positive number, because we have more bytes available, and now we cut out all the negative numbers, which means that we can store up till, I actually just went ahead and Googled it here because that was a little bit easier, but you can store the twice as much number when it comes to the positive number. So inside a column, you can define something called signed and unsigned when it comes to numbers that goes down into the negative range, because we want to maybe not allow negative numbers to allow more spacing for positive numbers. So that is something that is just important to mention here. So now that we talked about all of this, let's actually go and talk about how to actually create a table, because now you got a lot of dry knowledge about data types and signed and unsigned, and defining parameters and bytes and that kind of thing. So let's talk about how to actually create a database table. So if we were to go in here, we can define a create table. Keywords it's called, which basically means that we're going to create a table named something. So in this case, if we can name something called users, if that's what we want to create a table called. And this of course would be information about a user inside your website. So for example, username and password, email, the date that you signed up inside the website, that kind of thing. There is something to note here, which is if I were to write this, you may notice that we get a pop-up which says that this right here is a existing keyword inside our MySQL keywords here. So we don't want to be using a existing keyword. So this right here is a no-no, okay? So we want to make sure that we write something that doesn't pop up as an existing keyword. Otherwise you can end up in a little bit of, errors and that kind of thing. So make sure you don't do that. So one of the things that I do when it comes to naming a table is to say, well, inside a table, we have many entries of data, right? So we have many users inside this table, which means that it makes sense to call it users in plural, because we have many users inside this table here. So I like to name mine users. And it is allowed to use a underscore for something specific. So if you want to write something, you can use an underscore. But in this case, I think users is good enough. Parentheses and semicolon. And then I'll open up the parentheses, and then we can start creating all the different columns inside this table here in between the parentheses. So now we need to think about what kind of information do I want to remember about a user inside my website when it comes to a, database and information kind of purpose. The first thing I want to do here, which is something you need to do in pretty much all the different tables you create, is to make sure you have something called an ID. So I'm just going to go ahead and name this one ID, and then I'm going to define a int data type. And like we talked about, we don't really need to have something behind int here, but for the sake of making sure that legacy databases and that kind of thing can use this data for something, let's go ahead and make sure we define 11 in here just to make sure we have it defined. Even though it won't really matter to us in most cases as a web developer, we should still define it in here. So what I'll do is I'll go after and say that I want this data type to be not null, which means that we don't want it to be nothing. That's basically what null means. It means nothing. It is different than not having any sort of data. It just basically means nothing, which is a concept we have inside programming. But basically this means that we need to have data inside this particular column here. And what I'm also going to do here is I'm also going to define something called auto_increment. And I know I'm not really explaining all of this right now, so let me go ahead and explain it right after this line of code here. So basically, whenever we have a table, we want to make sure that we can find data inside this table very easily, which means that having a ID for all the different rows we have inside the table is going to make it a lot easier for us to grab certain data. So let's say I have a user that has an ID as 65, for example. If I were to look inside my database table for the user that has an ID as 65, which by the way, he's the only user who can have that number, then it's a lot easier for me to find that user inside the database than trying to search for his username or something. So whenever we're trying to search for something inside this table here, having an ID for all the different rows inside the table is going to make it a lot easier for us. So basically what we're doing here is we're saying that we want to have an ID for all these different users that is going to be a unique identifier. That is what ID stands for. And I want this to be a number data type. And I want to make sure that there is a number for all the users in here, because this cannot be empty. And now in order to not manually having to write a ID for every user whenever we create a user inside our website, I added something called auto increment, which means that our database is just going to handle this ID column by itself and automatically add a number to this user whenever we create a new user inside this table here. So user number 1 is of course going to be user number 0, and then the next user is going to have an ID as 1, and then number 2, and then 3, and then 4, and then it's going to keep counting up every single time you add a new user to the database. So this is automatically going to increment a number, hence the auto increment keyword. And this, by the way, is unsigned, which means that it's going to use the positive numbers and not negative numbers. So this is automatically also going to declare this as being a unsigned. And this is something that you have to remember, this particular line of SQL code, because we use this pretty much in every single table we create inside our database, because all our entries needs to have an ID. So having this particular line of code as the first thing is going to be very important. Now we do have something called a primary key that we need to define inside this table here, which is going to be this particular number, but we're going to wait with that until after we declared all the columns, because I want to talk about it afterwards. So for the people who do know a little bit of SQL here, we'll get to it. Okay. So the next one here could, for example, be a username. So let's say we want to declare a username for this user. So we can say username, and I want this to be a varchar data type, because this is, of course, going to be a set of characters, because we need to have crossing or something, as a username. So what I'm going to define here is just 30, because I want to allow 30 characters inside this username. More than that, I think is going to be, overdoing it a little bit. So if a user tries to declare something bigger than this, then it's just going to get cut off at the end there, because we don't want to have more than 30 characters. You could also say that maybe 20 characters is plenty, but let's just go and go with 30 for now. We do also want to declare this one as not null, because I do want to make sure there is some data inside this column here. And then I want to go down to the next line, and we can actually copy paste what we have here, because the next one is going to be very similar. And this one is going to be the password. Now there's a reason why I don't write password, and you may see it there because there is a built-in keyword called password. So instead, I'm going to declare a PWD, which is kind of a shorthand for password. And doing that, I do want to allow more than 30 characters. And when it comes to passwords, we don't want to really limit our user when it comes to a password. We want to allow them to create as long as a password as they want for security reasons, because the longer it is, the better it is. But let's not go overboard here. Let's go ahead and say we want to allow 255 characters, which we talked about is kind of like the maximum number for some databases. So let's go ahead and make sure we define 255 in here, which is plenty for a password, I think. So we don't need to have more than that. After this one, we can go ahead and go down to the bottom and maybe say something like email. And let's go ahead and define a varchar as well. So we're just going to copy paste here. And I want to allow something like, let's say 100 characters, because I think, an email with more than 100 characters doesn't really exist out there. So let's just go ahead and define 100 characters. And for the last column here, let's go and define a date time for when the user signed up inside our website. So we know when they signed up inside the website. So what I could do is I could create a column called something like created_at, just so we know, we have some kind of name for this column here. You can call whatever you want. In my case, I'm just going to call it created_at. And I'm going to call this one a date time format or data type, so to speak. And inside of here, what we can do is first of all define a not null, which means that it should not be empty. And we can also go and define something called a default, which means that if I decide not to write something and send it to my database table here to create a new user, then if left empty, it is going to by default assign something by itself to this particular column here. So what I could say is I could use the keyword called default and actually assign a default value. So in this case, I could say, just to give an example here, that we have a year, a month, a day. We do also have an hour, we have a minute, and a second. And this would be a default date time that I could set for this particular database here. But of course, this doesn't really make sense. Like this is, the year 0 at the 0th hour. So basically the creation of the universe or something. So this doesn't really make sense. But what we do have is another keyword inside the database here called current. And then you can see we get date and time. So one here is just the date format and the other one is the date time format. So we can say current time, which means that it is going to automatically create the time based on the server time. So this basically means that we don't really have to define a date time using PHP if we don't want to. We can do it because this is just a default, which means that if we don't submit something, then it's just going to assign the current time based on the database server. But you can also submit a date time using PHP if you want to. So you have kind of like an option now. But now we do also have something called a primary key. And the way you could define that is by, for example, going up inside the one column that has to be the primary key and just write primary key inside this particular column here. And now this is defined as a primary key. So this would be correct. But it is also just kind of a habit to go down here at the bottom and say that you want to have a primary key. So we can see we have primary key and we want to define a column. So we can say parentheses, and that is going to be the ID column, which is the one that we have up here. And doing this here is also a way to do it. So that is just a second way of doing it instead of writing it directly inside the actual column up here. And do note that I'm not writing a comma at the end because the last line of code inside this particular SQL statement here inside the parentheses has to be without a comma. So all the other ones, you need to include a comma, but for the last one, you leave it out. Otherwise, you're going to get an error message. Now, a primary key is basically just a way for us to define which column inside this table is going to be the one that we use that has to be unique. So it can't be duplicated elsewhere inside any other rows inside this database. So for example, we can't have one user that has an ID of 65 and then another user that also has an ID of 65. Because then we start getting error messages. So primary key is just basically a way for us to create a unique ID for all the different users in here. So we can very fast just grab a user and, find them very fast inside our database. So now with this created, we actually do have a database table we can just run inside our database and actually create it. Let's just go ahead and out of habit, just copy everything because in case something goes wrong, it is always a good idea to have this. You can also go ahead and store this information inside a empty text file or something. So you have, all this data somewhere. So in case something goes wrong and oops, okay. So this particular one up here could not have been named username. So I have to call it user_name or something instead. Then instead of having to rewrite everything, you have everything stored somewhere. So that is a recommendation that I have. So you have it saved essentially. So what I can do is I can scroll down and then I can say we want to go, which means that we're going to run this inside our database. And then you can see we now have our first database table, which is called users. If I were to click the database, you can see, okay, so we have our users table right here. And we can click it or we can click it over here on the side. And then you can see we have an ID, username, password, email, and created at inside this column here. Or inside the table, it's called. So right now you can see we don't actually have any sort of data. Otherwise, we could see it below here, just listed out. We're going to talk about how to insert data and update and all that stuff in the next episode. But for now, let's go ahead and create another table because we do also need to talk about something called a foreign key. So again, we want to make sure the database is selected. And because I made everything so tiny by zooming in, it's now a burger menu for some reason. If I would do this, to zoom out, you can see that I have it up here. But basically, we're just going to go ahead and click the SQL tab once more. I'll zoom in again so you can see it. And we're going to go ahead and create a second table. So in this case, I'm going to create a table. I'm going to call this one comments, because we're going to create comments that the user can make inside our website underneath something. So a picture or a video or something like that. So we're just going to go ahead and create a comments table, parentheses and semicolon. And what I'll do is, of course, I need to define an ID, because that's the first thing. So we're going to say we have an ID. This is going to be a int data type. And just like before, we're just going to set 11 as a default one. And we're going to say this one is not null. We're going to say this is auto increment. So auto underscore increment. So it automatically assigns a new number, comma, next line. And then I'm going to say, okay, so what do we need to know about this comment here? We need to know, for example, the username of the person who made this comment. So we could say username, and we can say this is a varchar data type. We're going to define a username length, which in this case it could be 30, because that's what we defined in the previous table. So we're just going to say 30 here as well, not null. And then I can go down to next line. And we do also need to have some text in here, of course, because you need to write a comment. So there has to be text in here, right? So instead of using varchar for this one, because we want to allow for the person to write many characters inside this comment here, we could also use a text data type. So let's go ahead and say we want to have the comment message, or just comment text. Let's go ahead and do that, because that's a lot shorter. So comment text, and I can say this is a text data type. I want to set this one to not null, and I want to go down to the next line. Let's also go ahead and create a timestamp for this particular when this was created. So we're going to create a date time data type, and we're going to call it something like created underscore at, because again, we can just reuse the same name as the previous one. And then we'll also go ahead and define a not null, and we can also go ahead and create a default. And then we can again use the same thing. So we can say current timestamp, or current time, it's called. So it will just automatically create a timestamp for this particular comment once it's actually created. And then at the end here, we're going to create our primary key. So we're going to say we have a primary key, which is going to be our ID. So we're going to define ID inside this particular one here. Now we want to also define a foreign key in this example here, because we can create something called a relationship between one database table and another database table. So right now we have a user who made this comment. So we're trying to think logically here, which means that we can actually tie a comment to a particular user. And you might be thinking, well, Daniel, we defined a username. Isn't that what you're saying? So if we say that a user called Crossing from the users table now is also named Crossing inside this comments table here, aren't those connected then to a human? That might be connected, but for a database that is not connected. There's no relationship going on between the two tables. So what I can do is I can actually say that, okay, so this comment here, let's say we actually upload a comment to this table here, has to be connected to a user that has a certain user ID. Again, the primary key inside the users table has to be connected to that particular comment. And there's a couple of reasons why we can do this. Let's, for example, say I go inside my website and I sign up as a user. And now I have a user account. Then I go inside a picture and I write a comment underneath the picture. Now, what is going to happen when I delete my user account? Is it going to delete all the comments inside the website that I made with that account? Or is it just going to throw me an error message because, hey, you made comments inside the website, so you're not allowed to delete your account? Or should we just go ahead and say that, okay, so we can delete the user account, but we now need to define all the comments the user made as a deleted user because the user no longer exists inside the website. So what needs to happen once we have this relationship and you decide to delete a user from inside the website? So what I want to do here is I want to first of all define a column that is going to reference another column inside my users table. And when it comes to naming this column here, we can give it any kind of name that we want to. But in my case, I think it makes sense to say that this is from the users table underscore, and it's going to be the ID for the users table. So just a little bit of logic here for me so I know exactly what this is. And what I can do is I can define a data type and not null and all this kind of thing. But it's very important that when it comes to the data type, that we assign it the same data type that is inside my users table for this particular column that I want to reference to. So in this case here, this is the ID for inside my users table, which means that we have the same type of data as we have up here, which is int 11. So we need to make sure that we define the same data type for this particular column here. Then I can also go ahead and say not null. And what I can do now is I can go down below my primary key and I can define a foreign key. So we can say foreign key. The first thing we need to define here is which of my columns inside this particular table is going to be my foreign keys. In this case here, I want to say this is my users underscore ID. This is the one that I want to reference to a key from another table. So what I need to do is write references, because we reference another table called users, and we point to a column inside this users table called ID, because that is the ID from inside the users table that I'm trying to reference to inside this column here. And now with this, we could just go ahead and submit it, and that would be okay. Everything would work perfectly fine. However, like I talked about previously, if I were to go inside my website and create an account and write a comment underneath a video or a picture or something, and I then delete my user account, what is going to happen now? Now, as a default, you're going to get an error message, because as a default, we have something called onDelete. And then we can write something like no action. And what this basically means, just to kind of explain this for you, is if I were to go inside and delete a user from inside my users table that has a certain ID that is connected to a comment that is made inside this table here. So right now there's a relationship going on between a comment and a user from inside the users table. If I were to delete the user, so on delete, then I want no action to be made. So essentially it's going to throw an error message and not delete the user, because we don't want to delete the user because there's a relationship going on here. So if we delete the user, then it's going to break our database table relationship. And this is basically the same thing as doing this right here, because this is actually the default state of what is going to happen if you try to delete a user that has made a comment. So that is not really going to make a lot of sense in most websites. Like logically in the real world, this is not going to make a lot of sense, because I should be able to go inside a website and delete my user account even if I made a comment somewhere. Like that should be a valid thing to do. So we do also have something called cascade. So on delete, I want to cascade, which basically means that if there's any comments inside this table here that has a relationship to a user from inside the users table that is now being deleted, then also go ahead and delete all the comments made by that particular user. So that is what cascade is going to do. But we do also have one called set null, which is basically going to, instead of, deleting all the entries or throwing an error message, this one is just going to go ahead and set this column in here as null whenever we delete a user that this one has a relationship to, which basically means that there's not going to be any sort of ID that we're pointing to inside the users table. It's just going to delete it from inside this column here. But now if I were to try and run this code inside my editor here, so let's go ahead and make sure we save it just to make sure. If I were to scroll down and actually run this, you'll notice that we get an error message. Oh no, there is an error, which is called error number 1005, which is actually when it comes to the foreign key being written wrong inside this table here. Now, if you know a lot about logic inside a table, you may see what is wrong here, because right now I'm telling it, if I were to delete a user from inside the users table, then go ahead and set the comment column, which is called users ID, to null, right? But what did we also define inside this column here? We said it cannot be null. So right now we're saying, okay, so if we delete a user, set this column to null, but hey, we're not allowed to do that. So if I were to do this down here, I do also need to make sure that we don't have not null inside this column here, otherwise we cannot do it. So we need to make sure we do this in order to submit it. So now that I have this, again, we can copy everything, go down to the bottom, make sure you have no comma at the end here, by the way, and go ahead and submit this. Then you can see everything works out just fine. So now if we were to go inside my database, you can see, we have two tables now. We have a comments and a users table. And these actually have a relationship with each other. We have a foreign key that points to another table. So now we actually have something going on here. And with this, we now know a little bit about creating tables inside a database, or you know a lot about creating tables inside a database. Of course, you can go much deeper into it, but for now, I think as a beginner sort of lesson that is already quite long, this is going to be plenty for teaching you how to create tables inside a database. So for now, this is what you need to know about creating tables. And in the next video, we'll talk about how to write some SQL code to just insert and select data. It's much more simple than this episode, by the way. This episode was quite long and complex compared to the next episode because we just need to write like one line of code in order to insert data into a database, into one of these tables here. So that is going to be much simpler, okay? So with that said, I hope you enjoyed this lesson, and I'll see you guys in the next video.